Okay, so our next topic is we need to find the equation of a plane. We need to find the equation of a plane in 3D. Okay, so imagine this thing. We are in a 3D space. So here, this is x, y, and z. Uh, Previously we have found the equation of a line, but now what is our main goal here? We need to find the equation of a plane in a 3D space. So this is a plane. Okay, so this is our plane. So in order to find the equation of a plane, we need two information. So this you need to remember, we need two informations. We need to information about this plane. So the first thing you need to know is the following. The first thing you need to know is the following. The point, any point on the xy plane, on this plane, which lies on the plane. Okay, that is suppose that there is a point x0, y0, z0 which lies on this plane, so you need this point, you need a point which lies on the plane. And the second information you need about this plane is you need a normal vector. Okay, you need a vector. Okay, you need a vector which is normal to the plane. What do we mean by the normal? Normal mean it is perpendicular to the plane. You can use this symbol, which is normal to the plane. So we need these two informations. Suppose that you can think about this in the following way. That is, there is a vector. There is a vector n. We call this normal, and its components are given by a, b, and c. So this is a vector which is normal to the plane, and the plane is passing through the point x0, y0, z0. Then how can we find the equation of a plane? So in order to find the equation of a plane, you can use this equation. So the equation of plane is given by the following. That is a multiplied with x minus x0 plus b multiplied with y minus y0 plus c multiplied with z minus z0, and it is equal to 0. When we substitute everything in this equation, we can find the equation of the plane. So in order to find the equation of a plane, we need two informations: a point and a normal vector. A point and a normal vector, and then you can find the equation of the plane. So let's do this problem. In this question, what he is asking us, we need to find the equation of a plane which is passing through the point 2, 4, minus 1 with the normal vector this. Okay, so you can think about this in the following way, that this point, it lies on the plane, that is 2, 4, minus 1, and this is our normal vector, and the normal vector, it is given by 2, 3, and 4. So what is the value of a? A will be equal to 2, b is equal to 3, and c equals to 4. And what is x0, y0, z0? x0 equals to 2, y0 equals to 4, and z0 equals to minus 1. So substituting everything here in this equation of the plane, what we are going to get? We will get 2 multiplied with x minus x0, which is equal to 2, plus what is b? B equals to 3, y minus y0, which is 4, c equals to 4, and z minus z0, which is minus 1. The next thing, you need to simplify everything. 2x minus 4 plus 3y minus 12 plus 4z, I think we get plus 4 equal to 0, and you can rewrite this thing in the following way: 2x plus 3y plus 4z, and if you simplify everything, this minus 4 cancels with the plus 4, you can bring minus 12 to the right hand side, it is equal to 12. It is equal to 12. Okay, so this is our required equation of the line. Okay, the above equation can also be simplified into this form, that is ax plus by plus cz plus d equals to 0, where d equals to this whole expression. And remember this thing, this is the linear equation in x, y, and z, because what is the degree of x, y, and z? It is equal to 1 in all of these variables. So this is the first thing you need to remember, that a plane is a linear object. It is a flat surface which does not have any curves or the bends. It is just like a line. In the line, it is like a straight thing. Similarly, a plane is a linear object. A plane, it is a linear object. And one more thing you have to notice that the numbers which are written with x, y, z, that will give you the components of the normal vector. Okay, that will give you the components of the normal vector. Let's do an example related to this one so that you can understand what do we mean by this. We need to find the equation of a plane that passes through the points 1, 3, 2, and this Q and R. So what does this mean? Let me draw this thing so that you can understand. We have, for example, this is a plane. It is a plane. Okay, find the equation of a plane that passes through these points. Okay, so this is the point P. Okay, let's say this is the point Q and this is the point R. This is the point R, and what he says that we need to find the equation of this plane. But in order to find the equation of a plane, we need a point through which this plane is passing. So for that we can use any one of these points. But the other thing we need is a normal vector to the plane. The normal vector, it is not given here, so you need to find the normal vector yourself by using the concept which we have learned before. That is, how can we find the normal vector to this plane? This type of the question we have done previously. In order to find this normal vector, first of all, what we are going to do, we will find the two vectors with the help of these points which are given in this question. So first of all, you can find a vector PQ, and then you can find the vector PR. Okay, you can find the vector PQ and then find the vector PR, and then later on we will find the cross product of these two vectors. We will find the cross product of these two vectors, which we know from our previous knowledge that it is given by this thing. In the first row we write ijk, in the second row the components of the vector pq, and then the components of the vector pr, and then we expand this determinant and it will give you this normal vector, which is actually equal to pq cross pr. So that's how you can find this normal vector. So this is the main idea of this question. So let's find PQ. So PQ will be equal to, we know that it is final minus the initial. So what do we get here? 3 minus 1, and then minus 1 minus 3, 6 minus 2, and if you simplify them you will get 2 minus 4 and 4. So these are the components of the vector PQ, and you need to write these components here in the second row, 2 minus 4 and 4. Similarly, you can find the component or the vector PR, which is given by final minus initial. That will give you 5 minus 1, 2 minus 3, and then 0 minus 2, and simplify this thing, it will give you 4 minus 1 minus 2, and put these components of PR in the row number 3. We get 4 minus 1, 4 minus 1, and minus 2. Now if you simplify this thing, okay, if you expand this thing, what we are going to get here, it will give you 8 plus 4 minus j. You can go on back and look at how did we find this, how can we expand this thing, the determinant minus j. Here we get minus 4 minus 16 plus k, and then minus 2 plus 16, and if you simplify them you will get this thing, 12i plus 20j plus 14k. So that are these are going to be the values of a, b, and c. Okay, that are going to be your values of, so a equals to, let's say, 12, b equals to 20, c equals to 14, and as a point you can choose the point P as your the plane through which it is passing. You can choose any other point. Let's say you can choose the point Q or the point R. So let's choose the point P. That is, the point P has the coordinates 1, 3, and 2. So it means that what is your x0? Your x0 will be equal to 1, y0 is 3, and z0 equals to 2. And substituting everything in the equation of plane, you will get the required plane. That is, we know that it is equal to a into x minus x0 plus b into y minus y0 plus c into z minus z0 equals to 0. Substituting everything here, we get 12 into x minus 1 plus 20, y minus 3 plus 14, z minus 2 equals to 0. Now if you simplify this thing, you will get 12x plus 20y plus 14z equals to I think here you will get 100. And if you simplify this thing, for example, if you simplify, if you divide this thing, if you divide all terms by 2, what do you get? You will get this thing 6x plus 10y plus 7z equals to 50. So this is our required equation of the plane. That's how you can find this thing.